Greetings to you all. Hope you all are safe and doing good. Let me start with a quote given by William Arthur Bird. Study while others are sleeping. Study while others are sleeping. Work while others are loafing. Work while others are loafing. Prepare while others are playing. Prepare while others are playing. Dream while others are wishing. Dream while others are wishing. With this motivational quote, I welcome you all to our science class. What unit we were dealing with last class? It was Unit 1 Measurement. Can we all recap what was learned in our previous class? Yes. So, what is measurement? Measurement is defined as the determination of the size or magnitude of a quantity. Physical quantity and units. Physical quantity is a quantity that can be measured and it has a numerical value and a unit of measurement. Then what is a unit? A unit is a standard quantity with which the unknown quantities are compared. Very good. What is the SI system of units? The abbreviation of SI is International System of Units and it was developed by General Conference on Weights and Measures at Paris in 1960. And there were three systems, right? CGS system, FPS system and MK system. List out some of the fundamental quantities. We saw 7 fundamental quantities. What are they? Length, mass, time, temperature, electric current, luminous intensity and amount of substance. What is a derived quantity and list few or some derived quantities? Derived quantities, as the name suggests, it has been derived from the fundamental quantities. So, the few derived quantities are area, volume, density, velocity and so on. Very good. Hope you are clear with the last video. So let's move on to today's session. The topics to be concentrated in this session are just two subtopics only, but these two subtopics are very important in our day-to-day life. Okay, so first topic is unit prefixes and the second topic is rules and conventions for writing SI units and their symbols. So first we move on to the unit prefixes. As the name suggests, prefixes, what do you mean? You would have heard these prefixes in your English class. I hope so. So what does it mean? A prefix is a letter or group of letters added to the beginning of a word, right? A prefix has meaning. For example, the prefix "un" means not. When a prefix is added to the beginning of a word, it changes the word's meaning. So when I add here I have word happy. When I add "un" to it, it becomes unhappy. It just gives the opposite of the word, right? Which mean not glad. So same prefixes are used in science as well. So let me ask you one question. What is your weight? You would be probably saying that maybe 45 kg. Okay, 45 is a physical quantity, right? 45 kg is a physical quantity where 45 is a numerical value and kg is the unit of measurement. But kg refers to kilogram, right? So gram is what the base unit. Gram is known as the base unit and this kilo is referred to as the prefix of the unit. So it is termed as unit prefixes. And second question also, if I ask like what is your height? Probably you will say it as 140 centimeter. Okay, this is a physical quantity and 140 is a numerical value and centimeter is a unit of measurement. Here too, meter is the base unit and centi is the prefix of the unit. So prefix is the centi. Centi is the prefix of the unit meter. Hope I'm making it clear to you. So in today's class, we are going to deal with unit prefixes. So what is unit prefixes? Unit prefixes are the symbols placed before the symbol of a unit to specify the order of magnitude of the quantity. They are useful to express very large and very small quantities. It stands for a specific positive or negative power of 10. In this tabular column, we'll have it as prefix and exponent. It will be easy to identify the exact prefixes with the exact exponent. So let's move on to the prefixes. There are few prefixes which have been tabulated here. Let's start with peta. Peta, tera, giga, mega, kilo, hecto, deca, deci, centi, milli, micro, nano, pico, and femto. These are few prefixes. We need to memorize it, and these prefixes are useful in our day-to-day life too. And these prefixes have a certain symbol for it. Like for peta, it is denoted as capital P. For tera, it is denoted as capital T. For giga, it is denoted as capital G. For mega, it is denoted as capital M. For these four prefixes only, it is denoted in capital letters. And other prefixes are denoted with a small letters. For example, for kilo, it is denoted as small k. For hecto, it is denoted as small h. And for deca, it is denoted with two letters, which is da. This is the only prefix denoted with two letters. Okay, so da for deca. Since d has been allotted to deci. Okay, small d has been allotted to deci. Deca plays or takes two letters as its symbol. Okay, centi is small c, milli is small m, micro is denoted with the Greek letter mu, and nano is denoted with small n, pico is denoted with small p, femto is denoted with f. So let's see the exact exponent of each prefixes. Let's start with peta. It is 10 power 15. Next is tera. It is 10 power 12. Next is giga. It is 10 power 9. Mega 10 power 6. Kilo is 10 power 3. Hecto is 10 power 2. Deca it is 10 power 1. And we have a exponent called 10 power 0, which is denoted as the base prefix. Okay, 10 power 0 is nothing but it is a base prefix. And since why this power is mentioned as 10 power 1, 10 power 2, it mainly denotes that it has 1 0 in it, it has 2 0 in it, it has 3 zeros in it. Okay, likewise for deci it is denoted as 10 power minus 1, 10 power minus 2 in negative values, 10 power minus 3, 10 power minus 6, 10 power minus 9, 10 power minus 12, and 10 power minus 15. In the upper tabular column, we'll just write the powers of the exponent alone. So for 10 power 0, the power is 0, right? Yes. For 10 power 1, it is 1. Then here for deci, it is minus 1. Here it would be 2. Then for centi, it would be minus 2. For kilo, it is 3. For milli, it is minus 3. For mega, it is 6. From after 3, it will be, there will be the multiples of 3. We will be getting the exponent, the powers would be multiples of 3. So 3, 6, 9, 12, 15, it goes on. Here For micro, it would be -6. For giga, it would be 9. For nano, it would be -9. Very good. For tera, it would be 12. For pico, it would be -12. For peta, it would be 15. For femto, it would be -15. Hope you are clear with this tabular column. And the main thing in this tabular column is you need to memorize these prefixes and the exact exponent form as well. Okay, and I just made a small statement to memorize it. If you want, you can use these statements to memorize this prefixes. Here is a statement. It says, in Pakistan, the great man King Hussein's daughter Beth drinks chocolate milk until night 9 p.m. Friday. So here I've just made something as a sentence. I've just put the symbols of prefixes into a sentence just to recall the order of the prefixes. For example, in Pakistan, this P refers to the prefix symbol peta. The refers to tera. G refers to giga. Okay, so PTGM. So Pakistan, in Pakistan, the great man King Hussein's daughter Beth. Beth refers to nothing but it is a base. Okay, drinks chocolate milk until night 9 p.m. Friday. And this daughter DA comes as for the symbol DA, deca. Okay, this is just to memorize this order of prefixes. Hope I'm making it clear to you. So SI prefixes, what is the abbreviation of SI? It is nothing but International System of Units, and you're clear with the prefixes as well. So let us move on to the next topic, rules and conventions for writing SI units and their symbols. So rule 1, some units are named after scientists like Watt, Newton, Pascal, so on. So this rule 1 mainly denotes with the scientists' names of and units, right? The units which is named after scientists are written with a small initial letter. See, for example, Newton, Henry, Watt, Pascal. The scientist names can be written with the capital letters, okay? But when it comes to the units, when we need to refer it as a unit, it should be mentioned as a small letter, okay? This is what the rule 1 states. The units which is named after scientists are written with a small initial letter. The second rule is, it is also deals with the scientist name but with the symbols. Okay, so there are several units named after the scientist, and the second rule mainly deals with the symbols. The symbols of the units named after scientists should be written by the initial capital letter. For example, see, for Newton we can write it as capital N. For Henry we can write it as capital H. For Watt we can write it as capital W. For Ampere we can write it as capital A. Let me move on to rule 3. So, rule 3. In this pandemic situation, what was the first rule government gave us? We need to maintain social distancing, right? So, how much meter we should maintain? Government gave us that you should maintain at least, yes, at least you should maintain 2 meter. Okay, have I written it correctly? Let's check. So the rule 3 actually says that small letters are used as symbols for units not derived from a proper noun. I have written it in capital M, right? So it is a wrong. It is wrong one. So let us correct it. So we need to write it as too small m. Okay, this is the correct form. Whereas this one is the wrong form. Okay, for example, see m for meter and kg for kilogram. Small letters should be used. This is what rule 3 states. Let's move on to rule 4. No full stop or other punctuation mark should be used within or at the end of the symbols. For example, see, is this correct? Compare it with rule 4, what it states, no full stop or other punctuation marks. So it has a comma in near kg and it has a full stop near meter. So it is incorrect. Then is this form correct? Meter kg? Yes, it is correct. This is what rule 4 states us. Move on to rule 5. The symbols of the units are not expressed in plural form. See here, in this meters, if I mention it as meters, I have traveled 5 meters from school to home. Meters, you cannot write it as ms for that. It is a meter. Just you should mention it as meters. And kgs for kilograms, you should not write it as kg. Yes, it is an incorrect form. Okay, the correct example would be meter, kg. You should not use any plural forms with the unit. Okay, this is what rule 5 states. So, hope you are thorough with 5 rules now. So let's check uh, or we'll just do a small activity. I have given a 2 statement here. The weight of Mala is 45 kgs. The weight of Mala is 45 kg. Which statement is true? Yes, the second statement is true. Why? Why does this first statement is incorrect? Because it didn't satisfy the fifth rule, which is the symbols of the units are not expressed in plural form. It is denoted in plural form, whereas this one is not denoted in plural form. So this one is correct and this is the wrong statement. I'll give you another example. Among these 2 sentences, which one is correct? A force of 2.5 Newton is needed to move the plate. A force of 2.5 Newton is needed to move the plate. So which one is correct here? Yes, the second statement is correct. Why? Because the first rule says that the units named after scientists are not written with a capital initial letter. So in this statement, it is written in capital letter. It is wrong statement. The units named after scientists should be written in small initial letters. Hope I am making it clear to you. So let's move on to rule number 6. It deals with the temperature. What is the SI unit of temperature? We would have seen in last class, right? The SI unit of temperature is Kelvin. So when temperature is expressed in Kelvin, degree sign is omitted. Okay, and there are other 2 scales to measure temperature, right? Which is Celsius scale and Fahrenheit scale. When we measure when we express it in Celsius scale, degree sign should be included. Celsius scale or Fahrenheit scale, both scale degree sign should be included. See the correct form and the incorrect form. The correct form. When you express it in Kelvin, you should not have degree sign. Whereas when you express it in Celsius and Fahrenheit, the degree sign should be included. Let's move on to rule number 7. solidus. Solidus is nothing but a division or slash is used to signify the division of units. Not more than one solidus is used. For example, here in first example, this is actually a correct form, meter per second. It can be written as meter per second, s power minus 1. This is the correct form. If in this third example, if you have two slash like joule per Kelvin per molecule, then this rule states that not more than one solidus is used. So it is an incorrect form. Third example is an incorrect form. It can be written as joule per Kelvin K power minus 1 mole per minus 1. This is the correct form. Okay, am I making it clear to you? So you should not use more than one solidus in a unit. Rule number 8. The number and units should be separated by a space. I have given you two examples. Which one is correct? Which satisfies this rule? It should be separated by a space. The number and the unit should have a space in between. Here it doesn't have space. So which example is correct? Yes, this is the correct example. Rule 9. Rule 9 states that accepted symbols alone should be used. For example, ampere. It should be written as the whole like ampere, or you can mention it with the symbol capital A, but not as amp or any other word. Okay. Likewise, second. This is the major mistake all students will do. For second, many students will write SEC. This is a wrong format. You should write the whole thing as a second, SECOND, or the capital S, which denotes seconds. Okay. Likewise for Pascal, not as pass. Okay. Let's move on to the last rule, rule number 10, which states that the numerical value of physical quantity should be written in scientific form. So for example, density of mercury can be written as 1.36 into 10 power 4 kilogram per meter cube, not as 13,600. Here, the scientific form, which denotes it should be written in the exponent form. Okay, the value can be written as same as like this. This is what the result it gives, but as per the rule, it should be written in scientific form. So this is the right form, whereas this is the wrong format. Hope you are clear with these 10 rules. And now it's the assignment time. Please take down these questions and write the answers in your classworks. So the first question is define unit prefixes. I've already explained that unit prefixes is nothing but the symbols placed before the symbol of a unit to specify the order of magnitude of the quantity. Yes. Second one is give 3 day-to-day life examples where you come across unit prefixes. I've already given height, weight and so on. You can add more example to it. Third assignment is list out the rules and conventions for writing SI units and their symbols. There are 10 rules which I have stated. List it out in your classwork, but give at least one example for each rule. Okay, and that's it for today's class. In next class, we'll be dealing with the measuring mass and the accuracy in measurement. Before that, I want you people to finish your assignment, and if someone has not completed the previous assignment also, please try to complete it before the next class. Thank you. Stay home, stay safe.